Bismillahirrahmanirrahim. We are studying chapter 8, that is automatic transmission, the transaxle principle. The basic slide of our course, the power train or the power flow of a rear wheel drive conventional vehicle, from where engine we have the power developed, then the flywheel and the clutch, gearbox, transmission, propeller shaft, differential box, distribute to the right and the left wheel. Now, the main slide of this automatic transmission, we have this engine, then we have this starter ring gear, the flex plate, the torque converter, then we have this hydraulic pump, the input shaft, and then we have a clutch pack, and then compound planetary gear system and the output shaft, and this is your housing in which we have oil and drive shaft. We have talked in detail regarding the torque converter and the planetary gear principles. Now we'll straight away go to towards today's lecture, that is compound planetary gear set. A compound planetary gear set is configuration that contains more than just the three basic members of a simple planetary gear system. Three basic members of a simple planetary gear systems are Sun, planet carrier, and ring. And a compound planetary gear set is basically combination or configuration that contains more than just the three basic members of a simple planetary system. Let's see what are those. A compound planetary gear set is one or more simple planetary gear set with one or more common gear. So in compound planetary gear set, it is basically a combination of one or more simple planetary gear sets with one gear in common, normally or usually. Compound planetary gear sets are capable of providing various combination of gear reduction, direct drive, neutral, reverse, and overdrive gear ratios. There are basically three types of compound planetary gear sets. One is Simpson gear set, second is Ravigneaux gear sets, third one is Lapelletier gear set. Now let's see the Simpson gear set. In Simpson gear set consists of a two simple planetary gear set. Let me have this pen. It's a simple gear set consists of a two simple planetary gear sets that shares a common sun gear. So in simple Simpson gear set, we have a common sun gear of two planetary gear set. This combination is capable of providing three forward gears as well as neutral and reverse gear. So with this combination in Simpson gear set, we have three forward gears as well as neutral and reverse. The basic operation, construction, and method of obtaining various gears ratios with simple planetary gear sets also applies to the Simpson gear set. The main difference is the number of the gear ratio that are available using more than one planetary gear set. So basically, by the combination of two planetary gear set, the only difference is in the gear ratio which we are having while using the one or single planetary gear set. Let's see this. A simple Simpson planet gear set is composed of two ring gears, and two-planet carrier assembled with that shares one sun gear. Okay, so we have this common sun gear, then we have this one planet carrier, the second planet carrier, the first planet carrier, the second planet carrier, and then we have this ring gear here and second ring gear here. So this is your input shaft and this is your output shaft. So we have one common sun gear, then we have two planet carrier and two ring gear in this Simpson gear set. Now Ravigneaux gear set. In this Ravigneaux gear system, we have following. We have two sun gears. In previous Simpson, we have only one sun gear, but here we have two sun gears, two planet pinion or planet carriers, one large than the other one. So one is larger in dimension and the second one is the smaller in dimension, supported in a one carrier. And we have a single ring gear here. So the difference here is in previous Simpson gear, we have two ring gears. We have these two ring gears here, but here we have one single ring gear. Okay, so let's see the figure. A Ravigneaux gear set is composed of two suns A Ravigneaux gear set is composed of two suns gear, one planet carrier that supports the two sets of pinion gear, and a simple ring gear. Now, we have this green one. This is your sun, and this is your input shaft. And these two yellow colors, the short pinion and long pinion. So this is your short pinion, and this is your long pinion. And then we have this ring gear, this with internal teeth. This is our ring gear, input shaft, and this is the reverse sun gear. Long pinion, short pinion, forward sun gear, two sun. We have two suns, the reverse sun gear and forward sun gear. Planet carrier, then we have, and then ring gear and output shaft. This is your output shaft. So in this design, it provides four forward gears, two in reduction, one in direct drive, and one in overdrive. So we get four combination, two reduction gear ratios, one direct drive ratio, and one overdrive. As well as it also provides the neutral and a reverse gear. Basic planetary gear set operations, constructions, and control methods also apply to this Ravigneaux gear set. So we get here four forward gears, in which two in reduction mode, one in direct drive mode, and one in overdrive, as well as neutral and reverse. So let's see the third one. Third one was Lapelletier gear set. Okay, in the Lapelletier, pronounced as Lapelletier, gear set was invented by this gentleman, a retired engineer, who devised a unique way to create a simple and efficient 6-speed automatic transmission gear set. It was first produced by ZF in 2002. The Lapelletier gear set is constructed by containing a planetary gear set in front of a Ravigneaux gear set. So basically, it's a combination of a planetary gear set in front of a Ravigneaux gear set. Besides ZF, General Motors and other also provided this type of. So this is the difference here. Now, another type of automatic transmission in which we do not have the planetary gear set, that is your non-planetary gear automatic transaxle. That Honda and Stern vehicle use automatic transmission with no planetary gear sets. So there is a difference in this make and type of vehicles. The Honda and Citroen, they do not use planetary gear set. This type is similar to and uses many of the same parts as their manual transaxles. So this is the similarity from the manual transaxle. This design uses hydraulic clutches instead of synchronizers. So they use hydraulic clutches instead of synchronizer to make the shift between the gears. By using the same parts as manual transaxle, this automatic transmission or transaxle has the following advantages. It allows both manual and automatic transmissions to be manufactured in the same plant, therefore reducing manufacturing cost. Honda automatic transaxles are diagnosed, and if an internal fault is detected, the entire assembly is replaced with the remanufactured unit. Honda dealership technicians do not repair automatic transaxle. So the only difference is we are using hydraulic clutches here instead of synchronizers. Now let's see, we are having this torque converter. This is your flex plate here. This is your torque converter, the rotor and the stator and the turbine. Input shaft coming to the gearbox. We have a clutch, series of clutch. This is your first hydraulic clutch. This is your second hydraulic clutch. Then third hydraulic clutch, fourth hydraulic clutch. And you have a main shaft, parking gear, counter shaft, secondary shaft, and then the power coming from here to this final drive and going to the right and left wheels. So a Honda non-planetary gear set types automatic transmission that uses helical cut gears instead of planetary gears. So instead of planetary gears, we use these helical gears, hydraulically applied clutches as commanded by the PCM, pulse control modulation, with fluid flow controlled by shift solenoid to make the shift. So hydraulic flow is controlled by the solenoid switches, which are controlled by electronically. The flow is controlled, hydraulic fluid is controlled by the shift solenoid, and the clutches are hydraulically operated, so there is no synchronizer, and the gear are helically meshed, so there is no synchronizer here. So hydraulic clutches do the all the synchronizer gear here. Another type of the automatic transmission, that is CVT, or the continuous variable transmission. It's a continuous variable transmission. CVT is usually found on some front wheel drive vehicles. So it is CVT, that is continuously variable transmission, is usually found on some front wheel drive vehicles that uses a transaxle. Instead of using 3 or more gear, a continuously variable transmission uses 2 variable width pulleys. So instead of variable gears, 2 or 3 gears, we are using 2 variables width pulleys, sometimes called variators, to change the gear ratio from 2.5:1 to an overdrive ratio of 0.52:1. So the purpose and function. The purpose and function of the continuously variable transmission is to allow engine to operate in a speed range where it is most efficient. Therefore, instead of causing the engine speed to vary as the transmission shift gears, the engine speed is more constant as the pulleys changes to increase the speed of the vehicle. So engine RPM remains within the range. There is no abrupt change in the RPM. Only the change is in the pulley arrangement, which increases the speed of the vehicle. The result of using CVT is improved fuel economy and reduce exhaust emission. So it lessens the burden on the engine and makes the pulleys to increase or decrease the speed of the vehicle like this. A driven pulley, wide and small in diameter, a drive pulley and driven pulley, narrow and large diameter, low ratio about, so it is reduction drive. In this case, the B case, the drive pulley narrow and oblique large diameter, and driven pulley wide and small diameter, so higher ratio. So we have overdrive ratio here. A belt and pulley continuously variable transmission uses variable width pulleys and a special chain to provide an infinite number of speed ratios. So with the combination of these two pulley of different variable diameters and specifications, we get different number of infinite number of speed ratios. Now, continuously variable transmission parts and operation. The two pulleys are moved at the same time. So they are moving at the same time. One pulley is made smaller in diameter, while the same time the other pulley is of enlarged diameter. This change in pulley effective diameter allows the drive chain to move, thereby changing the ratio between the input and the output pulley. So this change in pulley effective diameter, one is smaller, one is large, allows the drive chain to move, thereby changing the ratio between the input and the output pulleys. The chain is pushed rather than pulled through the pulleys and is made of hundreds of individual steel elements. We will see in this figure. The Honda CVT is constructed very similar to other electronically controlled transaxles, with the primary difference being the use of the belt and pulley system instead of multiple planetary gear sets or meshed helical gear, which we have seen in previous case. Let's see this diagram. So these are the steel loops which are there. Pulley Honda CVT belt transmission. So these are basically the steel loops and elements which are pulley contact area. So this chain is pushed rather than pulled through and is made of hundreds of individual steel elements. Now in continuous variable transmission, the transmission has total of 4 parallel shafts. One is input shaft, then we have drive pulley shaft, then driven pulley shaft, and secondary gear shaft. The secondary gear shaft is comprised of the secondary driven gear and the final drive gear. The final drive gear is meshed with the final driven gear, which is attached to the conventional open differential assembly. When the transmission is placed in park, the parking pawl interlocks with the park gear, which then holds the secondary drive gear stationary. Let's see the figure. Now we have this flywheel. This is your drive pulley shaft and drive pulley. We have a forward clutch, reverse brake, sun gear, input shaft. Then we have this start clutch, driven pulley shaft, steel belts, park gear, final drive, and final driven gear. So this is the arrangement like this when it is in the park and neutral. Now another type of transmission, automatic transmission, in which we have dual clutch automatic transmission. A purpose and function, a dual clutch automatic transmission or transaxle uses manual type transmission and two clutches that engages either the main input shaft or the counter shaft to achieve the following goals. So instead, in normal or manual transmission, we have a single manual clutch, but here we have a dual clutch automatic transmission or transaxle, which uses the manual type transmission, but with two clutches that engages either the main input shaft or the counter shaft to achieve the following goals compared to a conventional automatic transmission or transaxle equipped with a torque converter and a planetary gear set. So difference between the dual clutch and the automatic transmission or transaxle, we have a torque converter and the planetary gear set, but here we have a manual type transmission but with dual clutch. Okay. The advantages are improve the fuel economy, number one, reduce the cost of the assembly by using manual transmission components, improve the speed of the gear changes, instant gear changes, provides smoother operation due to dual clutch. The disadvantages of a dual clutch automatic transmission compared to a conventional or continuously variable automatic transmission CVT includes no torque multiplication advantage of a torque converter because we do not have a torque converter. We are using manual type of transmission with dual clutches. Not as fuel efficient as CVT transmission or transaxle. So it's a less fuel efficient. No torque conversion and less fuel efficient. A dual clutch automatic transmission uses two clutches that are mounted together concentrically. The larger clutch drives the odd number gear, first, third, and fifth, and seventh. The smaller clutch drives the even number gear, second, fourth, and sixth. Let's see the figure. We have the figure, this slide. The shift occurs without interrupting the torque from the engine by applying torque to the clutch while at the same time disconnecting the other clutch. These action results in a rapid shift without the slight delay using associated with the automatic transmission. So dual clutch automatic uses the best features of an automatic transmission without the power loss of a torque converter. So engine is on this side, power is coming to your clutch. This is clutch 1, this is clutch 2. Clutch 1 is linked with your odd number, clutch 2 is linked with your even number. So inner transmission shaft, outer transmission shaft, and from here it goes to the differential. So with this, we comes to the end of our lecture here.